Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter structure of atom. So in any steps, if you have any doubts, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please write the name of that chapter in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that when the azimuthal quantum number has the value of 2, the number of orbitals possible are. So it means the azimuthal quantum number, that is L, so L is equals to 2, then we know that the number of orbitals that is possible, that is equal to 2L plus 1. If the azimuthal quantum number is L, A is the azimuthal quantum number, then 2L plus 1 is, it gives you the number of orbitals. So L equals to 2, it means the number of orbitals will be 2 into 2 plus 1, that is 5. So option D is the correct answer. Then here it is told the correct set of 4 quantum numbers for outermost electron of potassium is. The correct set of 4 quantum numbers for the outermost orbit for potassium. Okay. So for the outermost electron of potassium. So for potassium, Z equals to 19. So if you write the electronic configuration, then it will be argon, its electronic configuration, that is argon 4s1. Argon 4s1. So the electronic configuration of argon, then 4s1. Or if you want, we can write 1s2, 2s2, 2p6, 3s2, 3p6, 3s2, 3p6, and then so yeah, 10, 18, 19. So 4s1. So for the outermost electron, that is 4s1, here the principal quantum number n is 4 and L is 0 and ML, that is also 0, and then MS, that is the spin quantum number, that is plus half. So 400 half. So option B is the correct answer. Then here it is told a body of mass x kg, mass is x kg, it is moving with a velocity of 100 meter per second. Its de Broglie wavelength lambda, that is equals to 6.62 into 10 power minus 35 meter. Hence x is how much? So therefore we know that the de Broglie wavelength of an electron, that is lambda, that is given as h by p, where p is the linear momentum of the electron. So de Broglie wavelength of the electron, that is equals to lambda equals to h by p, where p is the linear momentum of the electron. Linear momentum of the electron. So p equals to m into v. So therefore lambda equals to h by mv. M mass is given as x and v is equals to 100 meter per second, and lambda is given as 6.62 into 10 power minus 35, that is equals to h is equals to 6.62 into 10 power minus 34 divided by m, that is x into v, that is 100. So therefore 6.62 6.62 will cancel out, then I will get 100x, that is equals to 10 by minus 34 divided by 10 power minus 35. So this will be equal to 10. So 100x, that is equals to 10. So x equals to 10 by 100. So that is 0.1 kg. So option D is the correct answer. Then here it is told the wave number of the spectral line in the emission spectrum of hydrogen will be equal to the wave number that is nu bar, that is given as 1 by lambda of the spectral line in the emission spectrum of hydrogen will be equal to 8 by 9 times the Rydberg constant if the electron jumps from which level to which level, that is asked. So nu bar 1 by lambda, that we know, that is equals to r into Rydberg constant into 1 by n1 square minus 1 by n2 square. 1 by n2 square. And here n1 should be less than n2. So it is going from n2 to n1. So it goes from n2 to n1. It means n2 is the final, n2 is the, no, n2 is the initial orbit or the initial shell number, and n1 is the final shell number or the final orbit where it where the electron jumps to. So the electron jumps from n2 to n1, from higher orbit to a lower orbit. So now this is told that this should be equal to 8 by 9 times of Rydberg constant. And here in each of the options, the the final orbit, that is n1 is given as 1 only in all the options. In all the options. So therefore, if we take n1 as 1, therefore we can say that, so simply we have to find n2. N2 we have to find, then only we will get the answer. Then only we will get the correct option. So yeah, r into 1 by 1 square minus 1 by n2 square, or I can say n2 square, that is equals to 8 by 9 r. So r and r will cancel. Therefore, I will see that 1 by 1 square is 1 only. 1 minus 1 by n2 square, that is equals to 8 by 9. So therefore 1 by n2 square, that will be equal to 1 minus 8 by 9. So that is 1 by 9. So therefore n2 square equals to 9. Therefore n2 should be equal to 3. So it goes from n equal to 3 to n equal to 1. So option A is the correct answer. Then here it is told the set of quantum numbers for the outermost electron for copper in its ground state is the set of quantum numbers for the outermost electron for copper in its ground state. So the electronic configuration for copper is argon, then 4s2, okay, or I can say 4s1 3d10. Here it has an exceptional electronic configuration, since for copper the atomic number is 20 yeah, 29. Atomic number is 29, so we can write that it is argon 4s2 and 3d9. But here here since d orbital is not fully filled, so 4s1 3d10 will be more stable configuration, since here s is half filled and d is fully filled, so there is more stability due to exchange energy. So now for the outer, so here the outermost electron is the 4s1 only. So for 4s1 is the outermost electron, outermost electron in the ground state of copper, the ground state of copper. So the set of 4 quantum numbers, so the quantum numbers will be n equal to 4, which is the fourth shell, and L will be 0, since for s orbital s For S subshell, L is equal to 0, and ML also will be 0, and spin quantum number is plus half. So 400 plus half. So option C is the correct answer. Then here it is told which one of the following sets of quantum numbers represents the highest energy level in an atom. So for the option A, it is n equal to 4 and L equal to 0. So it is 4s orbital. And in the option B, it is 3p orbital, since L is 1, and C is n equal to 3 and L equal to 2, means it is 3d orbital. And for D1, it is 3s. Now, highest energy level. So here the value of n plus L is 4 here. Here the value of n plus L is also 4. And here the value of n plus L is 5. Here n plus L is 3. N plus L is 3 here. So now, according to the above principle, according to the above principle, uh, the correct order is 1s, then 2s, then 3s, then 3p, then 4s, then 3d, then 4p, and so on. So it means that it is the increasing order of the energy. So here it means that 3d has more energy than 4s. Even if here the principal quantum number is higher, then also the energy level, the energy of 3d is higher than that of 4s according to the above principle. Since why n plus L is higher. So option C is the correct answer. So here it is told that if the energies of the two photons are in the ratio 3 is to 2, here it is told that if the energies of the two photons are in the ratio 3 is to 2, their wavelengths will be in the ratio. Now the energy of a photon, that is given as hc by lambda. Now here it is told that, so therefore from here we can see that E is inversely proportional to the wavelength. It means the energy of the photon is inversely proportional to the wavelength. So therefore I can say E1 by E2, that will be equal to lambda 2 by lambda 1. Now here it is told the energies of two photons are in the ratio 3 is to 2. So it is 3 by 2, that is equal to lambda 2 by lambda 1. So therefore lambda 1 by lambda 2, that will be equal to 2 is to 3. So option B is the correct answer. Then here it is told the correct set of 4 quantum numbers for the outermost electron of sodium is. So for sodium, the atomic number is 11. Now that is its its electronic configuration will be neon 3s1. Neon 3s1, or I can say it is 1s2, 2s2, 2p6, and then 3s1. So it means the outermost electron is the 3s1. So it is in 3s1. Yeah, it is n equal to 3, L equal to 0. n equal to 3, L equal to 0, ML will be 0 also, and MS will be plus half. So it is option D is the correct answer. Then mm, then here it is told that impossible orbital among the following is. Now here the rule is that the value of L, which is the azimuthal quantum number, that will go from 0 to n minus 1. Now here for s orbital the L value is 0, for p orbital the L value is 1, and for d orbital the L value is 2, and for f orbital the L value is 3. So now it means that 2s is possible, 3f is not possible, 2p is possible, and 4d is possible. So 3f is not possible. So option B is the correct answer. Then here it is told the electronic configuration of Cu2 plus ion is. So for the electronic configuration of copper in the ground state is argon 4s1 3d10. So therefore Cu2 plus ion will have the configuration argon 4s0 3d9. 4s0 3d9. So option B is the correct answer. So since 2 plus, it means that it has lost 2 electrons. Then here it is told which of the following sets of ions represents the collection of isoelectronic species. Which one of the following sets of ions represents the collection of isoelectronic species? So um, Na plus will have 10 electrons. Then Cl minus also Cl minus will have 18 electrons, and K plus will have also 18 electrons, and Mg2 plus will also have 10 electrons. Then Sc3 plus will also have 18 electrons. And Ca2 plus also will have 18 electrons. Since why it will attain the electronic configuration of argon. Then then F minus will have 10 electrons. So I can say Na and Al3 plus. Al3 plus also will have 10 electrons. So I can say yeah, K plus and then Ca2 plus, then Sc3 plus and Cl minus. Yeah, so option C is the correct answer. So all these are These four are isoelectronic. Since why they have the same number of electrons. They have same number of e- electrons. So they are called as isoelectronic species. Then among the elements from atomic number 1 to 36, the number of elements which have an unpaired electron in their s subshell is, here it is told among the elements from atomic number 1 to 36, the number of elements which have an unpaired e- electron in their s subshell is. So in hydrogen H11, we have the electronic configuration of hydrogen is 1s1. So it has unpaired electron in s orbital, unpaired electron in s orbital. Then we have 1 to 36. 1 to 36, that from it means from hydrogen to it is going, so zinc is 30. So it is in the fourth period in the, so it is, so 36 is an inert gas in the fourth period, which is helium, neon, argon to krypton. Okay. From hydrogen to krypton. So hydrogen, then helium, no, then lithium also has electronic configuration helium, then 2s1, or I can say 1s2, 2s1. Then the electronic configuration for sodium also, that is neon 3s1. Then for potassium also, that is potassium also, it is argon 4s1. Then also in case of chromium, the electronic configuration for chromium is also argon 4s1 3d5. And for copper also, it is argon 4s1 3d10. So it means that unpaired electron in s orbitals are in these four and in these two. So it means in elements, in six elements from hydrogen to krypton, means from atomic number 1 to 36. In six of the elements, we have unpaired electron in s orbital. So option C is the correct answer. Then here it is told the statement that is not correct is angular quantum number signifies the shape of the orbital, signifies the shape of the orbital angular quantum number, which is that okay. So angular quantum number, it means the azimuthal quantum number, which signifies the shape of the orbital. For S it is spherical, and for P it is dumbbell shaped, which has got two lobes. So it means value of L, which is the azimuthal quantum number or the angular quantum number, it signifies the shape of the orbital. Then the energies of stationary states in hydrogen like atoms. Energies of stationary states in hydrogen like atoms is inversely proportional to the square of the principal quantum number. Okay. Uh, then C is the total number of nodes for 3s orbital is 3. So the total number of nodes is the number of nodes, the number of radial nodes, the number of radial nodes is given as n minus L minus 1, and the number of angular nodes, that is equal to L. So the number of nodes in 3s orbital, that will be n minus L minus 1. So n here it is 3. So it is n minus L, that is 0 minus 1, that is equal to 2. So it is not 3. So it means the C option is the wrong statement. And in D, it is told the radius of the first orbit of He plus is half of that of the first orbit of hydrogen. Yeah, so the radius, as we know, it is a naught n square by z. So radius of first orbit, so it is r1, that is equals to a naught by z. So for He plus the um, so it is a single electron species. Here z, the atomic number for helium is 2. So therefore R1 will be A naught by 2. So it is obviously it is half of the radius of the first orbit of hydrogen. So D is the correct statement. So A, B and D are correct statements, but C is the wrong statement. Option C is the correct answer. Then here it is told that two electrons have the following sets of quantum numbers. The two electrons. Okay, so for P, the n value is 3, n is equal to 3, and L is equal to 2. So here it is the electron in the 3D orbital. Since for S is equal, for S, L is 0, for P, L is 1, for D, L is 2. So it is a 3D orbital. The electron is in 3D orbital in case of P, and for Q, n is equal to 3 and L is equal to 0. So here it is in 3s orbital. So obviously for 3D, the n plus L value is equal to 5, and for 3s, the n plus L value, that is equal to 3 only. So obviously P has got greater energy. P has greater energy than Q, and P and Q represent same electron. No, it is false. P and Q have same energy. No, it is wrong. P has lesser energy. Then it is wrong. So th therefore the electron in the orbital P, has greater energy than that of Q. It has greater energy than that of Q. So it means option A is the correct answer. Then here it is told the energy of the electron in the nth Bohr orbit of hydrogen atom is Then here it is told the energy of the nth Bohr orbit of hydrogen atom is, so as we know, the electron in the nth Bohr orbit is given as minus 13.6 z square by n square, where for any hydrogen like species having the atomic number z. So for hydrogen atom, the atomic number z is 1. So therefore, the electron in the nth Bohr orbit is minus 13.6 by n square electron volt. Yeah, it will be in electron volt. Okay. So option A is the correct answer. Then here it is told consider the following sets of quantum numbers. Which of the uh, below setting is not a permissible arrangement of electrons in an atom? So here it is told that, so as we know, the value of L should go from 0 to n minus 1. L is the azimuthal quantum number which should go from 0 to n minus 1 only, where n is the principal quantum number. And the value of ml, which is called the magnetic quantum number, it should go from minus L to plus L. So the values of ml will be 2L plus 1 values will be there. And for L, there will be n such values, n values we will get. So here in the option C, as you can see, in option C, okay, in option A, as we see that L is 0, M is 0, and N is 4, which is okay, which is permissible, which is permissible. And in B option, it is told L is 3 and N is 5 and M is 0. Since L is 3 here, so M will go from minus 3 to plus 3. So yeah, it is permissible here also. And in option C also, here L is 2 and N is 3. And ML also will go from minus 2 to plus 2. So it is also permissible. But in the case of option D, we can see that L is 2, N is 3. That is okay. But here M is given minus 3, but it is not permissible. Since why M will go from minus 2 to plus 2 only. Since here L is equal to 2. So option D is not permissible. So option D is the correct answer. Then here it is told the correct set of quantum numbers for the unpaired electron of chlorine atom is, unpaired electron for chlorine atom is. So the ground state electronic configuration for chlorine is, mm, is neon, yeah, it is neon 3s2 3s2 3p5. So here unpaired electron is in the d orbital, in 3d orbital, which is 1 2 3 4 5. So the here we have 5, no, sorry, it is 3p5, sorry, it is 3p5, ps2 3p5, sorry. So it is, so here we have 3 orbitals in 3p. Okay. So so here we have one unpaired electron here. So we can say it is in shell number 3. So n equal to 3 here. And L can be, and here L is obviously 1 since P for P subshell L is 1. And ML, that also can be minus 1, 0 and plus 1. So ML is also 1. And MS, that is the spin quantum number, that can be plus or minus half. So option D is the correct answer. Then here it is told to particles A and B are in motion, if the wavelength associated with A, that is 33.33 nanometer, and the wavelength associated with B, we have to find whose momentum m- momentum is one third that of A. So momentum of B is one third of the momentum of A. Then we have to find the wavelength wavelength which is associated with B. So therefore wavelength associated with B, that will be equal to h by momentum of B, which will be equal to h by one third of momentum of A. So which will be equal to 3 times h by momentum of A. And wavelength which is associated with A, that is equals to the Planck's constant h by momentum of A. So lambda B will be 3 into 33.33 nanometer, since h by PA is 33.33 nanometer. So we can also say this will be equal to 33 1 by 3. It means this we can write it 100 by 3 also. So which is 100 nanometer. Means it is 100 into 10 power minus 9 meter, or I can say 1 into 10 power minus 7 meter. So option D is the correct answer. Then here it is told, with regard to photoelectric effect, identify the correct statement among the following. Number of electrons ejected increases with increase in the frequency of incident light. No, it is wrong. Number of electrons ejected increases with the increase in the work function. No. Number of electrons ejected increases with the increase in the intensity of incident light. Yeah, that is true. And energy of electron ejected increases with the increase in the intensity of incident light. No, that is also wrong. So it means that when some uh, photosensitive metallic surface, if you have some photosensitive m- m- metal, if we have, so then when some some electromagnetic radiation or some light is incident on it, having some frequency nu, and it is having some work function phi, then we can say that the kinetic energy of the ejected electron, that is equals to h nu minus phi. So it means the energy of the electron depends on the frequency of the incident light. Depend on the frequency of the incident light. So it means that if the frequency of the incident light is increased, then the energy of the electron will also increase. And the energy of the electron will also increase. Then okay. Then so here the energy of the electron will increase with the incident frequency increase. So if the intensity of the light increases, then the number of electron ejected will increase. So it depends on the intensity of the light. So the number of electron ejected increases with the increase in the intensity of incident light. So option C is the correct answer. Then here it is told the number of angular and radial nodes in 3p orbital are. So the number of angular nodes in any orbital that is given as n minus L minus 1. And for 3p orbital, we have n is 3 and p, and for p orbital, L is equal to 1. So therefore, it will be 3 minus 1 that is equal to 1. And number of radial nodes that is given, no, sorry, this is the number of radial nodes is n minus L minus 1, and the number of angular nodes that is equal to L is equal to L that is given as also 1. So option B is the correct answer. So there is one radial node also and one angular node also in 3p orbital. Then here it is told if wavelength of a photon is 2.2 into 10 power minus 11 meters, and the Planck's constant h that is given as 6.6 into 10 power minus 34 joule second, then the momentum of the photon is, then the momentum of the photon is P equal to h by lambda. So it is 6.6 into 10 power minus 34 divided by 2.2 into 10 power minus 11. This much kg meter per second. So it will be 3 into 10 power 11 minus 34. So that is minus 23. 3 into 10 power minus 23 kg meter per second. So option C is the correct answer. Then here it is told the number of 2p electrons having spin quantum number s equal to half is. So in 2p electrons, so here we can have 6 electrons, but only one of the electrons will have one of the electrons in every orbital will have the same spin quantum number minus half. Since why according to Pauli's exclusion principle, uh, no two electrons in the same orbital can have the same spin. They will, so the rule is that two electrons in the same orbital will have always the opposite spin. Since why no two electrons can never have the same, since two electrons in an atom can never have the same set of four quantum numbers. So s equal to minus half can be in 3 electrons in 2p subshell. So option 2 is the correct answer. Then nuclear theory of the atom was put forward by, the answer will be Rutherford. Rutherford gave the nuclear model of an atom by using his alpha ray, or what is called alpha particle scattering experiment. Alpha particles scattering experiment. So using this experiment only, he gave the nuclear model of an atom. Nuclear model. Okay, so option 3 is the correct answer. Then it is told which of the particles cannot be accelerated. So since neutrons has no charge, neutrons are chargeless subatomic particles. Neutrons are chargeless subatomic particles, so they cannot be accelerated. They cannot be accelerated. So since why the charge of alpha particle is obviously plus 2e, and the charge of beta particle, the charge of beta particle is minus e. which is simply an electron, and the charge of a proton, that is also plus E, where E is equal to 1.6 into 10 power minus 19 coulomb, and the charge of a neutron is 0. So option 4 is the correct answer. Neutrons are chargeless. In which of the following nuclear reactions neutron is emitted? So in the first one, here we can see that um, here we have, so neutron can be also written as N01, since why it has no proton and one neutron it is having. So here you can see 13 plus 2, there are 15 protons on the left hand side and on the right hand side also. And here the number of nucleons on the left hand side is 27 plus 4, which is 31, but here it is 30. So here only one neutron will should be emitted. And here also we can see that 6 plus 1 is 7, 12 plus 1 is 13 also. So here the reaction is balanced here. Here also the reaction is not balanced, but here the number of nucleons is the same. So here one positron should be emitted, which is also called a beta plus particle. And here also 96 plus 2 is 98, but here 97, and here also 241 plus 4 is 245. So the number of nucleons is the same. So here also one positron should be emitted, E10. So here also one beta plus particle is emitted. So neutron is emitted only in the first option. So the option 1 is the correct answer. Then it is told which of the following represents the Lewis structure of N2 molecule. So we know that nitrogen has 5 valence electrons. Nitrogen has 5 electrons in the outermost shell. So these 3 electrons it will share and it will form. So here the octet will be completed. Here also the octet will be completed. So it is the Lewis dot structure of nitrogen N2 molecule. So these 3 electron pairs have been shared to form 3 covalent bonds. We can also show it like this, and one lone pair on each nitrogen atom. So option 1 is the correct answer. Here it is told the atomic numbers of nickel and copper are, for nickel the atomic number Z is 28, and for copper the atomic number Z is 29. The electronic configuration, which is 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 3d10, that is how much? So it is the electronic configuration of which of these species that we have to find. So the electronic configuration for copper, that is 1s2, 2s2, 2p6, 2s, 3s2, 3p6, 3p6, then 4s2, 3d10. No, 4s1, 3d10. So for Cu plus, this will be the electronic configuration. Since why it will lose one electron from 4s orbital. And for nickel, the electronic configuration will be this, which is 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d8. 4s2 and then 3d8. So Ni2 plus will be 3d8 it will be. So option 1 is the correct answer. Then here it is told the electronic configuration for Cr3 plus is. So for chromium, the electronic configuration is argon. So for chromium, the atomic number Z is uh, so it is 24. So it will be argon, then 4s2 3d4 I can say, or it is 4s1 3d5 actually. 4s1 3d5, and then so Cr3 plus it will be the electronic configuration. So it has lost 3 electrons. So it will be argon 4s0 3d3. So option 3 is the correct answer. Then here it is told Mg2 plus is isoelectronic width. So Mg2 plus will have 10 electrons, and Ca2 plus calcium 2 plus will have 18 electrons. Na plus also will have 10 electrons, and Zn2 plus also Zn2 plus will have actually mm, will have 28 electrons, and Cu2 plus will have 27 electrons. So it means that Mg2 plus is isoelectronic with so sodium ion, which is Na plus ion. So option 2 is the correct answer. Then here it is told a body of mass 10 milligram, a body of mass 10 milligram, which is 10 into 10 power minus 3 gram. It is moving with a velocity. It is moving with a velocity of 100 meter per second. The wavelength of de Broglie wave associated with it wavelength of de Broglie wave associated with it is wavelength of de Broglie wave associated with it. So we know that the de Broglie wavelength, the de Broglie wavelength that is given as lambda equal to h by p, where p is the linear momentum of the object, p is equal to mass into velocity mv, so it will be h by mv. So therefore the de Broglie wavelength lambda will be h by mv, that is h is Planck's constant, which is 6.63 into 10 power minus 34 joule second, divided by mass, that is 10 power minus 2 gram. So we have to take it in the SI unit. So it is 10 power minus 2 grams. So it is 10 power minus 5 kg. 10 power minus 5 kg into it is velocity, that is 100. So 10 power 2. So this will come in meters. So that will be equal to 10 power minus 3. So it is 6.63. 3 minus 34, that is 10 power minus 31 meters. So the de Broglie wavelength is 6.63 into 10 power minus 31 meters. So option 2 is the correct answer. Here it is told in which of the following pairs both the elements do not have n minus 1 d10 and ns2 electronic configuration in its elementary state or its ground state. So so the group number in the group number which is 12, the group number 12, The elements are like this, which is Zn, Cd, Hg, and then Cn. So zinc, cadmium, mercury, and copernicium. Yeah. So here all of them will have ns2 n minus 1 d10 electronic configuration, Zn, Cd, Hg, and Cn. But the electronic configuration for copper, the electronic configuration for copper is argon 4s1 3d5, 4s1 3d10. So it is of the form ns1 n minus 1 d10. It is not ns2 n minus 1 d10. So I can say copper and zinc. Since wife, the electronic configuration for zinc is argon 4s1, no, 4s2 3d10. So it means that copper and zinc, they do not have the n minus 1 d10 ns2 configuration. Means only zinc has got this ns2 n minus 1 d10 electronic configuration, but copper does not have copper copper does not have n minus 1 n minus 1 d10 ns2 configuration. So option B is the correct answer. Then here it is told the number of protons, neutrons, and electrons in the ion S2 minus 1632 is. So it means that here it is sulfur. So the atomic number Z of for sulfur S, the atomic number Z is 16, and it has got S2 minus. It means that it has gained 2 electrons extra. It has gained extra 2 electrons in it. So therefore here the number of protons is 16, and the number of electrons is 16 plus 2, that is equal to 18, and the number of neutrons is also 32 minus 16. Since here 32 is the mass number A, the mass number A is 32. So 32 minus 16, that is equal to 16. So the number of protons is 16, number of neutrons is also 16, the number of electrons is 18. So 16, 16, 18. So option D is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter structure of atom. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And uh, uh, and please install our Sapience education application also, where we shall upload some important previous year questions based on the previous year KCT exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.